Alright, so this is going on page 59. When we're done, make sure you have a ruler and your angles and a glue stick. So yesterday, just kind of recap, we talked about a few shortcuts, because the only way before yesterday that we were able to prove triangles congruent is if we knew all three sets of sides and all three sets of angles were congruent. So yesterday we figured out a few shortcuts. Side, side, side works, side, and angle, side, angle. Okay? Not every combination of letters is always going to work. That's why we're checking different ones out. All right? But those three for sure work. So now starting here with set 4, make sure I gave everybody the right paper. It actually says part 2 up here, right? And then you're going to start up at the top with your ruler, and I want you to draw in a 6 centimeter line segment. Centimeters. And then yesterday at some point, I had some people in your group use a 60-degree angle and some people in your group use a 40-degree angle. So yesterday if you used 40, today right now you're going to use 60 and vice versa. Okay? That way we're kind of using this equal amount of angles is what I was hoping for. Yesterday on set 2 where some of us use different ones, if you use 60, now you use 40. If you used 40, now you use 60. That way you're using your angles kind of evenly. So I'm going to use 60. I don't know what I did in this class yesterday because I did different things all day. But I'm going to go with 60 right now. It doesn't really matter. And then you're going to take that angle, either 60 or 40, whatever is appropriate for you, and you're going to glue it down at one end of your line segment that you drew. And try and glue it down straight. Oh my gosh. Yes. Okay. And then you're going to repeat that down here. Come pretty close down here by where it says questions so that you don't have things overlapping. We're going to draw another 6 centimeter line segment. And glue the little angle down. Yes, you use the same, like if you're using 60, use 60 twice. If you use 40, use 40 twice. So these two things should be the same. Because what we're doing is each time we try one of these, we are starting with 3 pieces of information that we know. Like the first time it was 3 sets of congruent sides. The second time it was 2 sets of congruent sides and the included angle. And then 2 sets of congruent angles and the included side. So today, so far, we just have 2 pieces taken care of. We know that this side is, because eventually this is going to be a triangle, right? This represents the side of a triangle. So this side is congruent to this side, and this angle is congruent to this angle. Whether you use 60 or 40, it doesn't matter. Your 2 angles are congruent. That's all that really matters. Yes, ma'am. No, it doesn't matter if they're facing it. What do you mean facing each other? Like 60 on the right side of both? Well, the reason I'm having you do this is so that things don't overlap. You will probably be fine. It doesn't really matter. Just know that you may, if things end up overlapping a little bit, it's not the end of the world. It does make things a tad bit confusing, though, so you just have to make sure that you can go with it. All right, so now we're going to focus just on one of the 2 triangles. I'll just focus on the top one for now. And we're going to draw in a dotted line along the side of the 60-degree angle. Okay, so I'm going to use my ruler. And I'm going to draw in dotted line that represents where the side of the triangle would live. I have no idea how long to make it. All right. What I know, though, is that this side of the triangle lives on that dotted line. Right? However long it may be, it lives on that dotted line. The dotted line? We don't know. You just draw. That's why it's dotted, because we don't know how long it is. You just draw the dotted line. Because somewhere on there, maybe I stop here for the end point of the segment. Maybe it's here. I don't know. What I do know is that the side lives along there. Does that make sense to you? Okay. Now take an 80-degree angle. And whether you started with 60 or 40, you're going to use 80 as your other angle right now. That angle is going to be this part of the triangle somewhere. But I can't just glue it down. Because like if I glue my 80-degree angle down right here, then this side of the triangle isn't going to hit that part right there. You with me on that? But if I slide it down, what I know is that this 80-degree angle, I could slide it up and down this line segment like this. You with me? So if I leave that on the dotted line and I can put the other side of my ruler and I can slide it down, I'm going to slide it until the side of the triangle would hit the end point over here. Okay, so your 80-degree angle is going to have the two sides of your 80-degree angle right now are your dotted line and your ruler is going to have to hit the end point of that segment right there. If you're using the 40-degree angle, I don't think that these two angles, these two pieces, the angles themselves aren't this size, remember that, but the two pieces of cardstock that you have don't actually touch if you're using the 40. Even if you're using the 60, they may not, depending on how much you cut off. It doesn't matter, and they won't overlap necessarily exactly like mine do. But once you figure out where it goes, does everybody understand how this side of it is the dotted line, and then this side of it is the ruler, and the ruler hits the end point here? Once you've figured out where it goes, then I'm going to hold my angle down, and I'm going to move my ruler, and then I'm going to mark where the angle is so that I can pick it up and put some glue on it. So I'm going to pick it up, I'm going to put some glue on it, and then I'm going to glue it back down where my mark was, and then I'm going to double check that I actually put it back where it goes. And once I glued it down, then I'm just going to double check that it would still line up, and it looks like it does. Okay. Everybody understand how to know where to put it? This one's a little weird. The good thing is that this is now the third time today I've done it. I think I did a way better job of explaining it than I did the first time. Are we confused? Okay, so where's your 80? Okay, so your 80-degree angle. You can't just put it down the end because you don't know where it goes. The 80-degree angle has one side is the dotted line, one side is the ruler, right? So right now that doesn't work, but if I slide it down here, then it works. Does that make sense to you? Okay, good. Are we good? Everybody else okay? Yes. It can overlap, yes. And like yours overlaps more than mine does, but that's fine because you just have more of, oh, I'm sorry, dang it. Yeah. Yes, absolutely they can overlap. Or they may not, and that's fine too. Okay. Now we're going to do the same thing down here. So on the other side of the 60, you're going to make the dotted line because that dotted line is just where the side of the triangle lives, right? You take an 80-degree angle. The 80-degree angle, one side of it has to be on the dotted line. The other side of it would be like your ruler, which has to touch the other end point of the segment down here. And sliding it down becomes an issue when if it hits the other angle, because then you just got to pick it up a little bit. But slide it on down there. Oh my goodness. And just make sure when you line it up that it's lined up on that side, and that when you put the ruler down on the edge of it there, that it's going to hit the other side of the end of that line segment. So I have it right there. I'm going to mark it so when I pick it up to glue it, I know where to put it back down. Always double check yourself after you glue it back down, because for me anyway, with this glue stick, every time I stick it down, it moves a little bit, which is good, I guess, because I can fix what I didn't do right when I set it down. But you want to make sure you set it down where you meant to. Oh, let's see, mine's a little high. There we go. So you should have two that look pretty much the same. They may be turned around, they may be flipped on the other side. All that's fine. Because all that really matters at this point is that you have two sets of congruent angles. Do you delete? How are you going to do that? You don't have to erase the dotted line. You can if it bothers you or like confuses you, it's fine. But it can stay there. It's up to you. You don't what now? Like this? Is that what you're saying? Yeah, no. Okay, so what we are starting with, we know that 60 is congruent to 60, or maybe yours is 40, and then 80 is congruent to 80, and the 6 is congruent to 6. So we are starting with two angles and a side. The last one we did yesterday was two angles and a side. The difference is, yesterday it was two angles and the included side. It was like this side here that was included in the two angles. Today, it's two angles and the non-included side. Do you see how this side is not included in the two angles? When I say non-included, it is included in the triangle. I'm not saying it's not included in the triangle. That's what some people were thinking today. It's not included in the two angles, okay? This is the side that's included in the two angles. This is one of the non-included sides. The other side that we don't have drawn yet, that's a non-included side too. But this one is the one over on the 60. So what we have here is two angles and the non-included side. Understanding the difference between included and non-included is very, very important. So now that you've got that all set up, now you're going to take your ruler and you are going to draw in that missing side there that was represented by your ruler a minute ago. Like so. So that you actually get triangles out of it. Now, do your triangles look congruent? Yes. Okay. Do we have enough information right this second to say that they are for sure? Oh, actually, yes, because of what? The third angle theorem. Okay, good. Now, can we actually find the measure of the third angle? Yes, the third angle, and that's the third angle theorem totally works here too. But sometimes I have to use the third angle theorem because I can't even find the number because I don't even know the numbers. But let's go ahead and come up with the numbers too. If you use the 60 to start with like I did, what's your third angle? 40. If you started with 40, what's your third angle? 60. Okay, so I'm going to go ahead and label them in there. The actual number doesn't matter. All that matters is that they're congruent, and the third angle theorem totally works for that. Let's answer question number 1. My answer for question number 1 is 40. Don't just copy 40 because your answer might be 60. Then it says, what are the measures of the remaining two sides? Now, before we measure, because we're not going to, the whole point of measuring is to see if we have all three sets of sides and all three sets of angles congruent. But we don't need to go that far because Seth says we can use the third angle theorem. Now, the third angle theorem we need, and that's good. That doesn't really tell me that the triangles are congruent, though. So after I use the third angle theorem, now, how do I know that the triangles are congruent? You have 4 ways so far to say that triangles are congruent. Definition of congruent triangles, which makes you use everything. Side, 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 and angle, side, angle. Angle, side, angle. Because by using that third angle, I now have 2 angles and the included side. And we already discovered yesterday that 2 angles and the included side is totally enough information by angle, side, angle. Does that make sense to you? So it asks me for the measures of the remaining 2 sides. We're going to put a question mark. We don't really care. We don't even have to take time to measure them because we don't need it. Because yes, the triangles are congruent by angle, side, angle, congruence. Everybody okay with that? Now, and that's something, like on the other times, yes, I could measure them with a ruler and then use side, 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 but that's not something you're always going to be able to do. The third angle theorem, or subtracting and using the triangle sum theorem, those 2 things will work every single time, so you can always come up with that third angle, even if you don't have measurements. So this one right here, since it does work and it's enough, since it is 2 angles in the non-included side, this is angle, angle, side. The last one we did yesterday was angle, side, angle, and the order of the words matter because yesterday the side was included in the 2 angles. Today it's not included, so it's not included between the words either. So this is angle, angle, side congruence. Now, the 3 yesterday, those are all postulates. I can't mathematically prove them. But angle, angle, side is a theorem because you can use angle, side, angle to prove it. Okay? Because even if angle, angle, side didn't exist, we could use the third angle theorem every time to get to angle, side, angle. But make sure you understand the difference between the setup of these 2 because using this lets you skip the third angle theorem. That's good, right? But you have to be able to use this or use the other one. But they mean 2 different things even though they have the same 3 letters. Any questions about that at all? All right. I'll take that as a no. So flip it over. Set 5. Does everybody have 2 60-degree angles left? Yes? Okay. All right. So then, up at the top, with set 5, I want you to draw a 6-centimeter line segment. And draw it up pretty close to the top, like above where it says set 5. It doesn't have to be all the way against the edge of the paper, but I want to make sure that the dotted lines don't intersect if at all possible. And then I'm going to label that at 6 centimeters so I can remember what I did there. And then you're going to take one of your 60-degree angles and we're going to glue it down right here, like so. And then you can do the same thing pretty far down here by where it says questions, 6 centimeters. And glue a 60 down. So this one's starting off almost exactly like the last one we did. It's obviously not going to be the exact same thing, but same idea to start with. And the reason I had us use different angles on the front is because it didn't matter which set of angles we used, right? We still ended up with the same result in the end. Okay, so then this is 6 centimeters with my 60 degrees, 6 centimeters with my 60 degrees. So far I have a set of congruent sides and a set of congruent angles. Those were the first two things that we started with on the front. Then, just like on the front, we are going to lay our ruler down along the other side of the 60-degree angle and draw a dotted line. We don't know how long to make it because that's kind of the point that the side just lives on there. Lives on that dotted line somewhere. Instead of starting with two angles and the non-included side, on this one, we are going to start with two sides and the non-included angle. Which means that the dotted line is not the side I'm going to know. The side I'm going to know, and I'm just going to use a straw to kind of show you what's happening, is going to be this side right here. Okay? So that side length I'm going to give you, it's not actually going to be your straw because it doesn't actually work exactly with, depending on how perfectly you cut your straw. So we're going to use the ruler. The ruler makes it easier anyway, trust me. But that's going to be our third side length. So your second side length. So the side length that you know, and you're going to have to use your ruler because you're going to have to measure it anyway, is 5.5. So this side right here is going to be 5.5 centimeters. So I'm going to put the 0 at the end of that line segment, and then I'm just going to swing my ruler until the 5.5 hits that dotted line. And then when that happens, I'm going to draw that in and know that this is 5.5 centimeters. Okay, everybody okay with that? And do you see how this is two sides and the non-included angle? The included angle would be this angle up here, and that's not what we're doing. Now don't get ahead of me. Don't go doing the second one just yet. The angle? This side has to be 5.5, yes. And then you just have to decide, you have to swing your ruler a little bit to get it to where it would match. Okay, now if you want, so things won't overlap as much, you can erase some of that dotted line just in case it's going to go into the other one. You don't really have to, but it may overlap the other dotted line. So then we're going to do this, start off the same way down here. I'm going to put my ruler up here. I'm going to draw a dotted line just to extend the side because I know the side lives on there somewhere. Now this time when you go in to, like I can put 5.5 back down right there, but I want you to turn move your ruler around and see if there is a different place you could land the 5.5 besides where you landed it on the triangle above. Okay, so just make sure you put 0 on the ruler at your end point of the segment and kind of turn the ruler, see if 5.5 could show up somewhere else too. Can you find some other place? You were totally not listening to my directions whatsoever. That's another place? Yeah, that looks like the exact same place to me. Okay. That, and this one right here, this is 5.5. Starting from there. Okay. And then this one. And something else is not right. Okay, well that's pretty much the same as that one. Something's off on some of your measurements, but that's going to be, you're putting in the same spot. Do you get it? Okay, so look at this. If I put this here, right, and 5.5 right here, that's going to make it pretty much be the same thing I did above, right? If I swing it out more this way, 5.5 is never going to touch that again. But if I swing it in like this, then 5.5 is going to end up right about, what, there maybe? Okay. So, oops, 5.5 right there. Can you make it the same? Yes. I told you to make it different. Okay, so then this side length here is 5.5 centimeters. Swing it in. Let me see what you have. Well, and yeah, it may be a little bit different depending on how accurate your measurements were on everything else. But see, that's not 5.5. That's like 5.1. You swing it in to get to 5.5. Right, and that would be exactly the same as what you have there. So you got to keep going. So it's a really skinny triangle, but is it a triangle? Yes. Okay, and I think that might be, well, it goes a little bit. It's just not as much. Like your 6 may not be exactly 6, or your 60 may not be exactly 60, but it is in a different place than this, and that's okay. Anybody having trouble? Okay, so if you go back and if yours isn't looking anything like mine, you might want to go back and remeasure and make sure your 6 centimeters is really 6 centimeters. And if it's not, that's okay. I was just giving you a 6 centimeters so y'all weren't starting with 12 and then nothing fitting. But as long as the two segments are congruent, like if you measure wrong the same way twice, then you're okay as long as they're congruent. And then same thing with your 60, depending on how the angle was cut, it may or may not come in exactly. But either way, this segment is congruent to this segment, and this side is congruent to this side, and the angles, right? This is two sides in the non-included angle. Now, we're not really supposed to go by the way things look, but we are constructing these, like for real. We're using a ruler, maybe not very accurately, but we're using one. I mean, we are using straws and little cardstock that we cut out, so it's not exactly perfect science here, but for the most part, it should look like what it's supposed to look like, right? So if we are going to just think about that much right there, are these two triangles congruent? No, they're not congruent at all. Did I have two sides congruent to two sides and the angles congruent? Yeah. Now, could I have put 5.5 in a place here to make the two triangles congruent? Yes, okay? But I could also swing it in here, and without this angle being something that's already set in stone, it doesn't tell me that I can't change that, right? So this little setup, it does not work. If it did work, then as far as the little acronym goes that we've been doing, it would be SSA congruence. That does not work. That spelled backwards is ass, and there is no ass in geometry. Okay, write that right here. No ass in geometry. For real, write it down. No ass in geometry. But you know what? No matter how many times I say that, somebody on the test is going to write ass, big as day, box it, be all proud of their answer, and move on. If you are about to write a bad word on your test, you're wrong. Okay? A couple reasons you shouldn't be writing bad words on your test. Second of all, it does not work. This is the ambiguous case. Now, if I had drawn the 5.5 in the other spot, the triangles actually would have been congruent. However, only knowing those pieces of information is not enough to say for sure that they are congruent. So remember, when we're saying like that we can't prove them congruent, we're not necessarily saying that the triangles aren't congruent. We're just saying we can't prove that they are based on what we know at this point. Does that make sense to you? Just like, although this works, oh, not that, I didn't actually flip it over. Although this one works, before we started talking about these shortcuts, if all I had given you was 2 angles on the non-included side last week, that wasn't enough because the only way you knew how to do it was all 6 pieces, right? And that doesn't mean that they're not congruent, it just meant you couldn't prove it at that point. Now you can. Here, you can't, you've got to have more information than this for it to work. Does that make sense to you? Yeah, I'd have to have the other, like if it was the included angle, it'd be side angle side, and that one works because that lets it not close. Okay, it can only be one thing. So it says down here, what is the measure of the third side of each triangle? Well, you can measure the third side if you want, but it's not even necessary. We're just going to put a question mark. We don't care. All that we care is that they're different. We can tell by looking. Only when it's actually a for real construction to scale. What are the measures of the remaining 2 angles? We don't know that either because we don't have a protractor. Are the 2 triangles congruent? No. Okay. Well, we do care. We care that they're different. What the actual measurements are is not important. Then number 4 says, do you think that you would get different results if you used a different angle? Well, if we'd have used a 40-degree angle, do you think the same thing probably would have happened? What if it was 110 degrees? I mean, do you really know? Because you probably didn't really expect for it not to work, right, since everything else worked. So we're going to put maybe, because we're going to come back and revisit this at another time. We'll have to see. Because this, by all means, is not an actual proof, right? I mean, this is a proof it doesn't work, so clearly I don't have to do anything else. But even on the other ones where I might have used a 60 and you used a 40 and it worked for both of us, that's only showing that it works for those 2 angles. That's not still a real proof that it shows for every angle no matter what. So not very scientific here, but we know that it can't work for just in general, and then we'll have to look at some other angles a little bit later. Okay, we all good on that? All right, now does everybody have 2 of each angle left? Take out 2 of each angle. If you do not have enough, borrow from a neighbor. Yeah, you will have some extras. And we may come back and end up using some of them for some similarity stuff, so we don't want to throw them away or anything. 2 of each. 2 of each. I think everybody else is fine except for maybe Patricia because I stole her stuff yesterday. You good? Okay. All right. So now just put 3 of the different colors aside, so you just have 3 angles, 3 of the different angles. And you're going to arrange these angles because these 3 add up to give me 180. I know they're going to make a triangle. I arrange them until how they would actually make a triangle and the sides would line up. The easiest way to actually do this is to start with 2 of them, like with 60 and 40. So put some glue on a 60. And then glue it down right about there. Okay. And then put some glue on a 40. And then put your ruler down so that you know that this would actually like represent the side so you can get them level. And then just glue your 40 down next to it. So that way you've got like a side of a triangle. I'm not drawing in a side at any point, but it gives me that. Then you take your 80, and I can't put 80 up here because then that doesn't make a triangle, right? I need to slide it down. I know it's going to have to be lined up on this side and be lined up on this side. So you got to figure out how far you have to bring it down or up or whatever so that it would actually create a triangle. Now, it might not literally, there may be gaps, that's fine. I'm not saying they have to literally make a triangle and that's all you see, but you need to be able to have a continuous line segment on each side. Once you figure out where 80 might need to be, you can mark it so that you can put glue on it and put it back down. So when you put it back down, always double check that you put it down where you intended. And your little angle pieces might overlap, and they might not, depending on how far apart you put stuff. It's fine. Okay. There's that. Everybody okay with that? Now, did you all put them pretty close together? It's okay if you didn't, but since I think most people did. All right. Are these 2 all? Well, you can't just put it. Yeah, you can put that anywhere, but yeah, after those 2 are glued down, then you can do that. All right, so if you put these 3 pretty close together, then when you do your next set, just make them different. So if that's where my 60 and 40 was then, I'm going to spread them out a little bit like that, maybe a little bit more. And then I'm going to glue those down. Just make sure if you were to draw in the sides, which we're not, but if you were, that you would actually get a line segment. It's not like jumping around. That's why putting the ruler down to actually make a straight base would be good. Yeah, and mine does right there. It's fine. And it might overlap both of them. And it may not overlap any of them. That's all fine too. It all has to do with how much you cut off your angle anyway. So here again, I can't just plop my 80 up there. I've got to make sure that it would actually line up with both sides of the triangle. So we'll do something like that. Yeah, and you're going to do another one. Just make it different than your first one. The easiest way to make it different is just to spread the first two out a little bit and then just go with whatever happens. So as you're doing this, if I gave you a full-size sheet of paper, could you spread the 60 and 40 out even more? And then the 80 would just have to go higher, right? So these, even though we don't even, it kind of looks like we have sides drawn in on a couple of them, but they're not really even drawn in. I don't even know the side lengths. It asks us in those questions to measure them, but I'm not even going to bother doing that because are they going to be the same when I measure them? No. Could I arrange the second set so that they would be the same? Yes, so it is definitely possible. Will it always be the same just because the three angles are the same? No, because there's 180 degrees in a triangle. Regardless if it's a little tiny or ginormous triangle, there's 180 degrees. So the two triangles here are not congruent, but what are they? Or what? Heard it. Similar. Because the angles maintain the shape, it's just a different size, right? So this is not congruent, but similar. And so if this did work, then this would be the three angles. That's all we knew. We didn't have any side lengths. Angle, angle, angle congruence. But that does not work. So to answer the questions down at the bottom, it says, what are the measures of the three sides for each triangle? Well, I'm going to put a little question mark again. They're different. I don't know what they are. I don't need to know exactly what they are because we are doing this to scale, and so they're just different. That's all that matters. And so are the two triangles congruent? No, they're not. Everybody okay with that? And then on the front, I want you to put at the top, because yesterday we listed off the ones that we had done. The first one we did today was angle, angle, side congruence. Then we looked at side, side, angle congruence, which does not work. And we looked at angle, angle, angle congruence, which also does not work. So get those listed out, and then don't glue it in just yet, because I'm going to give you something else to cut before we glue. Maybe. I forget where I put them. So I'm not giving you the assignment today because we don't have enough time to wrap this up and actually discuss it and do some examples and let me show you how we're actually using it. So I don't want to give you an assignment that would just confuse you anyway. We're going to go ahead and get this part right here folded, cut, and glued, and then we'll start tomorrow by discussing this and then doing some examples and stuff. All right? So don't be gluing anything into your ISN yet. Just grab the piece of paper I just gave you and follow along with me, and then you'll have time to glue everything in the end. Huh? Okay, we'll have to look at that in a minute. Take the piece of paper I just gave you, fold it in half, like it goes in your ISN, and crease it. And then open it back up. And take each side and fold it into the center and crease it. Like so. Okay? And then we're going to cut. Don't cut until you hear my instructions so that we can make little doors on the front. There are not lines to cut on the front on purpose because anytime I put them on the front and on the inside, they never line up. So that you don't cut through words and confuse yourself, listen. Once you have it folded, then you want to open it up and just cut along the lines until you get to the first crease. Do not cut all the way to the second crease, or you will end up just cutting this whole thing apart. So we cut, 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 so that it would look like that on the left-hand side. Does that make sense? And then you do the same thing on the right-hand side, and when you are done, this is going on page 60. So once you're done folding and cutting this, then you can glue what we did today on page 59, and then glue this on page 60. And then we will start by discussing this tomorrow. And then take all of your extra little stuff, put it back in your little baggies, put the little baggies in the big baggies, and I will come around and get them. And I will wrap all this up and make it make sense tomorrow.